Hello and welcome to Section 10.3 of Business Management. Sections 10.3 and 10.4 are the heart of why you study calculus because of its optimization capability. So let's take a look at this first graph. If this were the graph of average cost and you wanted to minimize the average cost, that would happen right here. Note that the slope is 0. And then if you have a profit function, you want to maximize profit, you would want to be right there. Note that the slope is also 0. However, there are other points on the graph where the slope might be 0, but that's not where you want your cost to be. And this wouldn't be where you want your, you wouldn't want your profit to be here either. And in the past, when we have wanted to maximize a function, we used x equals negative b over 2a. We can't use that anymore because this is only for quadratics, and neither of these functions that we're looking at is quadratic. So instead, we will say that f has a maximum or a minimum when its derivative is equal to 0. We're going to find these 0 slopes and use that to tell us the optimum points on the graph. Here comes our first example. We're given a revenue function and asked to find the level of sales x that will maximize the revenue and then to find the maximum revenue. So to do this, we will set the derivative, which is the marginal revenue, 2600 minus 22x minus 3x squared. That will give us our slope at any point on the graph, and we'll ask algebra to help us find where that slope is 0. So I want negative 3x squared minus 22x plus 2600 to equal 0. You could try to factor it, but those coefficients are a little bit unwieldy. I'll use the quadratic formula, but first I'm going to go ahead and divide by -1 just because I prefer to work with positive numbers whenever possible, and I can multiply both sides by the same number if I want to. Okay, so x will be opposite of 22 plus or minus square root of 22 squared minus 4 times a, which is 3, times negative 2600, all over 2 times 3. That gives us negative 22 plus or minus, this is 178, all over 6. So x is either negative 22 plus 178 over 6, which is 156 over 6, which is 26, or x is negative 22 minus 178 over 6, which is negative 200 over 6. Okay, however, in this problem, we're talking about a level of sales, and we can't have a negative level of sales, so I can take that answer and I can discount it. Now I've got a single answer of x equals 26, but what I don't know yet is whether that's a maximum or a minimum. So what I really ought to do is put that critical value on a number line and then take a number on each side and test to see whether it's increasing or decreasing, and then I can say it's a max. However, in this course, when we're at this point in the course, you've already demonstrated that you know how to do this part of the course. I guarantee you, if you only have one answer under consideration and the problem asks for a maximum, then the answer that you have yields a maximum, not a minimum, but a maximum. So the level of sales will be 26, and that's 26 units. And then for the next part, find the maximum revenue. For that, I need the value of regular R, and I get that by plugging it back into the original function. 2600 times 26 minus 11, 26 squared minus 26 cubed. And I get $42,588. That's $42,000 of revenue from selling 26 units, and that's the best revenue I can ever get. And just for the record, that's question number 1 on your homework. Okay, next, what if we aren't given the function that we're supposed to analyze? In this one, it says the total cost function for producing X lamps is, And then it wants to know producing how many units will result in a minimum average cost per unit. Okay, now careful with that. That's a minimum average cost. This is not an average cost function, that's a cost function. So we first have to build the average cost. And as you recall, that's C bar, and it's found by taking the total cost and dividing by the number of units. So I will take total cost, 720 plus 32x plus 0.2x squared, and divide by an x to create average cost. This will be easier to take the derivative of and to simplify it if we separate it into separate pieces, each with a common denominator of x. So if I think of taking the x, and instead of dividing the whole side by x, divide each term separately by x. Now I have 720 x to the negative 1, I can cancel an x, plus 32, plus cancel an x, 0.2x. Okay, at this point, all I have done is build the function that I want to analyze. Now I want to minimize it, and the minimum will happen when the slope, which is the derivative, c bar prime, is equal to 0. So I take the derivative of the function that I built, negative 720 x to the negative 2. The 32 goes out, plus 0.2, and I set that equal to 0. And now I'm faced with an algebra issue. How do you solve this? It will be easier to think about if you take the x to the negative 2 and put it back down in the denominator. Subtract 0.2 from both sides. Negative 720 over x squared will be negative 0.2. Multiply by x squared to get the variable out of the denominator. Negative 720 is negative 0.2x squared. Divide by the negative 0.2. X squared will be positive 3600. Then I can square root it. X will be 60, or okay, negative 60, except x represents a number of units, and so the negative doesn't make any sense. So now I have a single value for my critical point, and they were asked for a minimum, so that means my minimum will happen at that critical value of 60. And then the next part, find the minimum average cost per unit. So now I need to be careful which function to plug it back into. If I plug it back into C, I will get cost. I don't want cost, I want average cost. So I want to plug it back into this function. And you can do that in any one of these formats, but I kind of like that original one. So C bar will be 720 plus 32 times, plug in 60 for x, plus 0.2, plug in 60 for x squared, and divide it by 60. I got C bar is 56. And then the question is 56 what? Well, that's an average cost. So it's $56 per unit on average. That's the lowest I can ever get. And that will happen when I am producing at a level of 60 units. Okay, for our next example, we're still trying to figure out optimum values, a maximum or a minimum. This time we are given an average cost function. Pay attention that this is an average cost, not a cost. It's an average cost. And we're given a demand function. We've got lowercase p, that's price in a demand. So I've got average cost and I've got price, and they want me to maximize the profit. So the first question on all of these is, do you have the function that you're being asked to analyze? In this case, no, we were not handed a profit function. So we'll have to build it. Profit is revenue, take away cost. Do we have a revenue function and a cost function? No. We have a price function and an average cost function. So revenue is price times quantity. Cost is average cost times by x. Let's just take a look at that for a minute. In the last problem, we said average cost was cost divided by x. So if I want to solve for cost, I could multiply both sides by x. Total cost is average cost times x, which kind of makes sense because average cost is a cost per unit times number of units. That would give you total cost. Okay, price we have, that's from our demand function, 450,000 minus 100x times quantity is x. Take away average cost we've got, that's 1,000 over x plus 200x plus x squared. Average cost times by another x. Let me clean this up so we can get it calculus ready. That will be 450,000 x minus 100 x squared minus, I'm going to take this x and put it in front so I can take the negative and the x together and distribute it through, minus 1,000, the x's will cancel, minus 200 x squared minus x cubed. We're almost there. Profit is negative x cubed minus 100x squared minus 200x is minus 300x squared. That's those two. Plus 450,000 x minus 1,000. Whew. After this much work, I have built the function that they want me to analyze. Notice that it is not quadratic, which means I can't do the negative b over 2a thing. I'm going to have to use the slope instead. So to find the max, take the derivative and we'll set it to 0. Negative 3x squared minus 600x plus 450,000. When will that equal 0? Okay, I can divide everything by negative 3. That will cut my numbers down a little bit more, make it easier to work with. So the derivative will be positive x squared plus 200x minus 150,000. Set that equal to 0. You can plug that in the quadratic formula. I'm going to go ahead and factor it just for the sake of time, but you'll get the same answers if you do the quadratic formula. Positive 500, negative 300. So x is either negative 500 or x will be positive 300. So again, even if you don't, even if you can't factor with 150,000s, you can still get these same answers just by using the quadratic formula. Notice that, again, the negative answer I can throw out because I can't have negative 500 units. I've only got one answer. That's an x. X stands for the number of units. So the first part of the question will be how many units? That would be 300. The next part, find the maximum profit. So what I have so far is the number of units. To find the profit, I take 300 and plug it into the original profit function, which I erased. Let me get that again. Okay, here's the profit function recreated. So we need to plug in our 300 into this function. And I took the liberty of doing that, and I got 80,999,000, and that's dollars profit. So we got an answer for x, and then they wanted a maximum profit, so we had to plug it into our profit equation. Okay, next, what selling price should the corporation set for its profit, for its product? So now I need to know, how do I find the price? Well, the price is the little p from the demand function. It's this function, the 450,000 thing. So price will be 450,000 minus 100 times 300, plug in x. 450,000 minus 300 with two more zeros, 420,000. I don't know what they're selling, but that's a hefty item. Okay, last. So we're kind of building as we go. To recap, we started off by being handed a revenue function and then asked to maximize it. And then next, we were asked to maximize a profit, but we had to build that. No, excuse me. We were asked to minimize an average cost, but we had to build the average cost function first. Then we had to build a profit function in that last problem that was pretty intricate to build. And now here we are, we're given a paragraph, no equations, and we are asked to maximize the profit. So I need to figure out how I build a profit function. And then I will take its derivative, set it to 0, and that will give me a maximum. Okay, profit is revenue, take away cost. I don't have a revenue function, I don't have a cost function, but revenue will be price times quantity minus cost will be cost per unit times quantity price. It says I can get 680 per month, but that's going to change. So here's part of the problem is that the rent, which is our price in this problem, is going to change based on, and the number of apartments will also change depending on how many times I increase the rent. So if only I had a little p price function like I had in the last problem, I could plug it in here, and then I could times by the quantity, which is the number of apartments, which I'll call X. And then for cost, I do know that the cost of maintaining the apartment building is $12 per unit. That's a fixed, always 12. And then I will have X number of apartments rented. The question is, how am I going to get this price function? And this goes back to what we did on exam 1, where we want to create a demand function that takes price and quantity and interrelates them. And what I know is I can do that if I have 2 points. Quantity, 50 units, then the price is $680. Yeah, now it sounds familiar, huh? But I'll only have 49 units rented if I raise the price by $20, so that would be $700. I take those 2 data points and I use them to create a line. I need to find the slope. 700 minus 680 over 49 minus 50. That's 20 over -1, -20. Take your slope, pick your favorite data point. I'll pick this one. And y minus, plug in the y coordinate, will equal slope, -20, times x minus, plug in the x coordinate. And clean it up. Y minus 680, -20x plus 1,000. Y is equal to, I'll write it right here. Y is equal to -20x plus 1680. And when I say Y, what I really mean is price. So price is -20 times the number of apartments plus 1680. That is what needs to go into our price function. Profit, finally, is -20x plus 1680 price times quantity. That makes revenue so far. Take away 12 times x. -20x squared plus 1680x minus 12x. -20x squared plus 1668. Here's my profit function. Okay, let me clean up for a minute. Okay, after that much analysis and building of equations, we finally have the function that we're trying to optimize. From here on out, it's pretty straightforward. To find the maximum, you set the marginal profit derivative to 0. So negative 40x plus 1668 would have to be 0. Subtract. Negative 40x be negative 1668, and then divide. X will be 41.7. Okay, now this is a really good time to talk about the difference between theoretical mathematics and real life. So if X could be 41.7, that would be the exact best. But X represented a quantity, which in this case was a number of apartments, and I cannot rent 0.7 of an apartment. So I go to the nearest value that makes sense. We're going to call it 42 apartments, which is fabulous. Then I go down here, and that's not what they want. They want what rent should be charged per month. What I know so far is that I'll only have 42 apartments rented. Okay, so to find the rent, I can do that two different ways. I can go back and find the function that talked about price, which was this original little p function that we built from the 2 points. So my price, which is the rent, will be negative 20 times, plug in 42, plus 1680, negative 840 plus 1680 makes 840. That's the optimum rent to charge to get the most profit. Your other option is to say, if 50 apartments could rent for $680, then 49 would rent for $700, 48 would rent for $720, 47, and so on. You have dropped the price 8 times to get down to 42, and each time you have increased the price 8 times to get down to 42 apartments. So you started with $680 of rent, and 8 times you increased the rent by $20 each, so that 8 people moved out. 680 plus 160 makes 840. Okay, these problems in 10.3 and 10.4, there are videos, I think, on every single one of them. If not, let me know. But good luck. Send me your questions either to my email or through Ask My Instructor. See ya.